You are about to be fixed. Physics Fixed. Better than real. Where each brief episode brings insight you've never had before by smashing through conventional barriers. It's Occam's razor in the hands of Jack the Ripper. Since we don't have to be stupid about quantum spin any longer, Phyxed kicks off field theory with unification as its goal. Just as quantum mechanics gave rise to quantum field theory, chronaxial spin leads to fields. Neither quantum mechanics nor relativity give any hint to explain gravitational or electric charge. Convention relates gravitation to the structure of spacetime, while attributing other fields to undetectable virtual particles. Such different models are hardly a path to unification. Dark matter presents another barrier to unification. For a single field to model both gravity and electromagnetism, the presence of one without the other must be explained. That's about to be fixed. Though it's a useful abstraction, a field is not just numbers assigned to locations in space. These are tangible, physical values, like a contour map, where the field of applied numbers are real physical elevations. To understand fields, we first learn to make one. Imagine spinning a rope overhead so fast it's only a blur. You just made a rope field. The rope is a radial field element which sweeps out a field over its angular distribution. If possible, instantaneous spin would yield a continuous field, with average density decreasing as distance from its center. The rope would no longer have a simple position, it would instead be in a superposition, occupying all radii at once. Instantaneous motion is no longer moving, it's being. In this case, being a field, a new object unto itself. So field density, or intensity, increases toward the center, but not to infinity, as the proportion suggests. Instead, field density increases to 100% of its field element, the rope. This substitution sensibly explains an otherwise embarrassing physics procedure called renormalization. Now let's vary field shape or morphology. If the rope merely oscillates along its length, the average field density will be constant along its linear rotation. Our original field resulted from classical planar rotation. By contrast, solid angular rotation of the rope about a fourth dimensional axis would produce a 3D Gaussian field, for which intensity falls off characteristically with radius squared. If you're wondering how a field element can pass all locations on a sphere at once, recall that with instantaneous rotation, it's just a larger 3D superposition than with a plane. In fact, rotation about time as the fourth dimensional axis is inherently instantaneous. A field element with chronaxial spin yields a typical Gaussian field. Of course, a material rope can't serve as such a field element. So let's consider the opposite. As rope contributes mass to its field's density, the opposite would be a field element which subtracts from field density. That's simpler than it sounds. Let the continuum have positive density. A plastic disc might represent this. Now let a radial notch in the disc be a subtractive field element. When the disc spins, the field element reduces average field density, which is close to 100% at the periphery, falling to 0 at the center. Note that the notch is as large or small as its continuum, having no inherent size. Defined as something that's not there, it may be considered a type of null vector. We still don't have a continuous field because this system also can't be instantaneous. But if you've been with Phyxed since episode 1, you have all the tools necessary for a theory of everything, unifying all four interactions. Congratulations! You've been fixed! Next time, our massive undertaking will be the most elusive field of all, gravity, modeled from first principles. I'll see you there, if you dare. Ha ha! Find some field theory links in the description below.